Hi Algebra 2, this is Unit 2, Lesson 3, and we're going to talk about function composition today. So function composition is really just going to be two functions, one following the other. So I'm going to have an input and I'm going to do a function, and that's going to result in an output, and that output is going to become the input of the second function. So I'm just going to read the top here. Since functions convert the value of an input variable into the value of an output variable, it stands to reason that this output could then be used as an input to a second function. This process is known as composition of functions, in other words, combining the action or rules of two functions. So there's different notation that we can look at. So I have this f following g of x on the left, and on the right I have f of g of x. In both of these both mean the same thing. They're just two different ways of writing it. I always start with the function on the right. So basically, let me look at on the one on the right here. I'm going to start with g of x. That's going to be my first function. And then whatever answer I get for that goes into f. Same thing here. I'm going to start with g of x. And then whatever answer I get, that output from g of x becomes the input for f of x. All right, so let's look at a problem, and this is going to remind you of a geometry problem. I have a circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. And I want to determine the area of this garden to the nearest square foot. So now remember, it's a circle and I'm trying to find the area. So area of a circle, if you ever forget it, it's just on your reference sheet, is pi r squared. The radius of this circle is 15, so pi times 15 squared is 225 pi. Now they want me to round this off to the nearest square foot, so I'm just going to put this in my calculator, and I get 706.8, and nearest square foot means I have 707 square feet. That's the area of my garden. Okay, so my first function was finding the area of the garden. Now, using my answer from A, I want to calculate the cost of covering the garden with topsoil. Well, topsoil costs $1.25 per square foot is the topsoil. So I'm going to take that area of my garden, 707, and I'm going to multiply it by $1.25. So of course you would just do this in your calculator. And it would cost $883.75 in order to cover that garden with the topsoil. What I have here is I really just have two functions. I have a radius of 15. This is my input. I put it into the first function, which is finding the area. So that's the first rule, is finding the area. And I get an output, that's my area, of 707 feet. Then that becomes my new input to put it into the second function to find the cost of covering that garden with topsoil. And when I put it into my second function, cost, I get my final output, which is the cost of $883.75. That does seem expensive. This must be a fairly large garden. Okay, but I really just have two functions. So in this exercise, we see that the output of an area function is used as the input to the cost function. Right? So the output of the area is used as the input to the cost. This idea can be generalized to the generic functions f and g as shown in the diagram below. So I have this input x. I put it into my first function, and that output becomes the input to put into my second function, and I have a final output of y. Okay, so let's practice doing a little bit of this on the next page. So next page, remember I got two functions. I'm always doing the one on the right first. So I got two functions here. My first function is f of x equals x minus 2, and my second function is g of x equals 2x plus 3. So the first function I'm going to do is the one on the right. Let me get a darker color here. So I'm going to do this g of 1 first. So g of 1, okay, so I'm doing the g function first. 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. So g of 1 is 5. This is my output. So 1 was my input. 5 is my output. That output becomes the input for the second function. So now I'm going to do f of 5 is 5 squared minus 5, which is 20. Okay, so I got two functions, one following the other. I can actually do two of the same functions in a row like I have on B. So I'm going to do g of 0. So I'm doing 2 times 0 plus 3. So 0 is my input. 2 times 0 is 0 plus 3 is 3. 3 is my output. And now that's going to become my input for the second function. But look, my second function, this is the first function right here. And this is the second function right here. My second function is also g. So g of 3 is just 2 times 3 plus 3, which is 9. Okay? On C, different notation, but this is my first function. My first function is on the right. My second function is on the left. So I'm going to do g of negative 2. So that's 2 times negative 2 plus 3, which is negative 1. And then that output becomes my input for my second function. F of negative 1 is negative 1 squared, and just be careful with this because the whole thing is being squared. So negative 1 squared is positive 1, and 1 minus 5 is negative 4. And the last one that we're going to practice with the second notation is f following f of negative 1. So this is my first function, f of negative 1, and then whatever output I get is going to become my input, but I am going to do the f function again. So f of negative 1 is negative 1 squared minus 5. Negative 1 squared is 1 minus 5 is negative 4. And that becomes my input. That output becomes my input for the second function, but my second function is also the f function. So f of negative 4 is negative 4 squared minus 5. That's 16 minus 5 is 11. Okay? Same idea, but let's try it on some graphs. Now graphs you just don't have to plug in, you're just going to read the graph. So you might find it a little bit easier, I don't know. First thing, why don't you write this in? It didn't really, wasn't clear on your paper. Y equals f of x. So the graph on the left is y equals f of x. And the graph on the right is y equals g of x. So those are my two functions. So again, f of 2. So this is my first function. And this is my second function. So I'm going to do f of 2. F of 2, I have to read the graph on the right, on the left. F of 2. So here's 2. 1, 2, 1, 2, 3. F of 2 is just equal to 3. Now I'm going to take that output, and that output is going to become my input for the second function, so g of 3. Now g of 3, I have to go to this graph on the right. G of 3, 1, 2, 3, 1, 2, 3. Is right here. G of 3 is equal to 3, and that's my final answer. Let me change up my color. So for B, I'm going to do g of 1 is my first function, and then whatever answer I get, I'm going to plug into my second function, which is also g. So I'm going to be looking at the graph on the right. So g of 1, go to 1, 1, 2, 3, here's g of 1. G of 1 is equal to 3. That output is going to become my input for my second function, which is also g. Here's my second function. And g of 3, so on my graph, 1, 2, 3, 1, 2, 3. G of 3 also is 3. Change my pen color. So now for C. C, I'm going to do f of negative 2, that's going to be my first function, and then whatever I get, I'm going to plug into g, that will be my second function. So f of negative 2, here's negative 2, and here's my answer. So f of negative 2 equals 1, I'm going to take that output and I'm going to put it in for my input on my second function, which is right here, g of 1, which I already did previously. So g of 1, I'm looking at the graph on the right, is right here. G of 1 is 3. Grab another color. Let's see what we haven't used. Let's use this purple. F of 0 is my first function. And then whatever I get, I will plug into my second function, which is also f. So f of 0, so f, I'm looking at the graph on the left. F of 0 is right here. F of 0 equals 2. And then I'm plugging that into f, to my second function, which is also f. F of 2, so I go to my graph, is right here. F of 2 equals 3. All right, I have a few more to try on the next page. On occasion, it is desirable to create a formula for the composition of two functions. We will see this facet of composition throughout the course as we study functions. The next two exercises illustrate the process of finding these equations with simple linear and quadratic functions. All right, so let me just change this color. I have two functions. I have f of x equals 3x minus 2, and then I have g of x is 5x plus 4. So I want to do one function following the other, but you can see that I am not going to actually get an answer. I'm going to get a formula, and that formula should be y is equal to ax plus b form. So I'm going to start with g of x, okay? G of x is just 5x plus 4. So that's my output. This right here is my output, and that output is going to be used in my second function. So now I'm going to do f of 5x plus 4. So and I'm going to look at my f function, which is 3x minus 2, but wherever there's an x, I'm going to substitute 5x plus 4. And I have to use my distributive property. 3 times 5x is 15x. 3 times 4 is 12. And this is just going to be y equals 15x plus 10. And I did it. So I took the g rule and I plugged it into the f, and I got my formula, y equals 15x plus 10. Well, the next one just wants me to do flip-flop and do the opposite. So I'm going to start with f of x. So f of x is 3x minus 2. And I'm going to plug that in to g of x. So I'm going to do g of 3x minus 2. So I'm going to plug this into the g. 5 times 3x minus 2 plus 4. Again, I'll have to do the distributive property. So I'm going to get 15x minus 10 plus 4. So I'll get y equals 15x minus 6. All right, and looking at these, we can see that they are not the same. Okay, so that means that a composition is not commutative. It matters the order in which I do things. Composition is not commutative. It matters which comes first. Whoops, is not commutative. It definitely matters which comes first. Okay. Let's try a multiple choice problem. So f of x equals x squared and g of x equals x minus 2. So those are my two functions. I got g of x, I got f of x. So I'm going to start with g of x. That's the one on the right. So g of x is x minus 5. I'm going to take that and I'm going to plug it into f. So I'm going to do f of x minus 5. So I really have x minus 5 squared, because that's the rule. Look at the rule for f of x. F of x is to take it and square it. So I'm going to take x minus 5 and square it, which really means I'm going to take it and multiply it by itself, which I'm going to have to do what I was practicing in Unit 1. I'm going to do foiling. X times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. So I get x squared minus 10x plus 25. And that is choice 4. And then the last one, I'm just going to read a table. So I just did some equations, I did some graphs, and now I finally have a table here. The accompanied diagram defines the functions f and g, and I want to find g following f of 3. So I got to start, this is my first function, f of 3. So I'm going to find f of 3. Remember, this is my input. So I'm going to go to the f function, and f of 3 is 5. I'm looking right here. Here's my input, right? There's my input right there. And that gives me an output of 5. And then I'm going to take that output, and that output is going to become the input for the second function, which is g. So I'm going to do g of 5, right? This is my second function right here. So g of 5. So now I'm going to look at the table on the right. G of 5 is right here because this is my input. 5 is my input. And I get 8 as my output. All right, so just remember, when you're doing function composition, the input goes in, the output comes out, that output goes into another function, and your final answer comes out. You can do this with tables, you could do this with graphs, and you can do this with equations. So try the homework problems that go along with this, and if you have any questions on any of the homework, please make sure you circle it, highlight